My name is Naol Ketema, and this is Project 1.2, the analog oscillator. As seen, the printed circuit board, or PCB, is made up of two 100 microfarad capacitors, two 2N3904 transistors, and two LEDs. It also uses four fixed resistors that are made up of two 1K ohm resistors and two 10K ohm resistors. You can also see that it uses a single pole double throw, or SPDT slide switch, and three terminal blocks. The whole circuit has three ways to power. The first way is like this. Second, and third. Current comes through the 1K ohm resistor, through the LED, and goes into the capacitor and the collector lead of the transistor. Since the capacitor is connected to the base of the second transistor, it turns it on and begins the oscillation. The same process is mirrored on the other half of the circuit. The transistor is a crucial component of the circuit. The ones used in this circuit are the 2N3904s. When looking at the flat side of these transistors, moving from left to right, the collector lead receives the current while the emitter emits current. A signal current is necessary at the base in order to begin the movement of the current from the collector to the emitter. When enough voltage is applied, it creates a path of current in the main circuit to flow. The base emitter voltage has to be approximately 0.7 volts. The arrow in 2N3904 points from the base to the emitter, unlike the 2N3906 transistor, which points from the emitter to the base. Capacitors, on the other hand, store electrical energy. Unlike batteries, capacitors store energy differently, but also charge and discharge much faster. The higher the capacitance, the more energy the capacitor can store. And in the analog oscillator, a 100 microfarad capacitor is present. To calculate a capacitor's charge time, we have to use the equation tau is equal to resistance times capacitance. Tau would be 10 to the third times 10 to the negative 4. These numbers are derived from the 1K ohm resistor and the 100 microfarad capacitor. When we multiply those numbers, we get a tenth of a second. We multiply 0.1 by 5 because it takes approximately 5 time constants for the capacitor to reach 99.3% of its maximum charge. Thank you for listening, and I hope this video helped you understand the analog oscillator.